Dear children, in this video we are going to see the example 1.17. So, if f from r minus 1 comma 1 to r is defined by f of x is equal to x by x square minus 1. So, why the domain is like this? Range can have all real values, but the domain they are given all reals except these two numbers. So, if I take either minus 1 or plus 1 in x place, in denominator 1 square or minus 1 whole square, if I substitute the x values and then minus 1, the denominator becomes 0. So, the whole function it doesn't exist. Okay, so for x values plus 1 minus 1, this particular function will not exist. So, that's the reason domain all real values it can have except these two plus or minus 1 should not contain to r. Okay, but the range is nothing but we can get all reals in range. Now, this particular function we have to verify whether it is 1 to 1 or not. Okay, so now we all know to find out for the 1 to 1 function, we have to consider f of x is equal to f of y, and then if we get by the end like x is equal to y, then we'll say that the function is 1 to 1. Okay, so now let's consider here f of x is equal to f of y. Now in this function f of x is nothing but x by x square minus 1, which is equal to y by y square minus 1. Now after this here what we can do, we'll just do cross multiplication. So x into y square minus 1, which is equal to y into x square minus 1. Okay, next here we can multiply x inside, so that you'll get xy square minus x, which is equal to yx square minus y. Now bring all the other two terms, bring these two terms to the left hand side, so that you'll get xy square minus x and then minus y square plus y equal to 0. Now from these two things, let's take here from these two terms, let's take xy as common. Okay, it is very clear, we can take xy as common. If I take xy common, here you will get y minus x. Okay, here you have y square term. Let me write it clearly. Here you have y square term. Okay, so therefore y minus x, and then here what else you have? The rest of the terms are like again y minus x equal to 0. This y minus x equal to 0. Now if you see from here, this is the first term and this is the second term. We'll put this as one particular bracket. Now clearly I can take this y minus x as common. So if I take this y minus x as common, you'll get xy plus 1 equal to 0. So now I can equate both the terms to 0. So you'll get y minus x is equal to 0, as well as xy plus 1 equal to 0. So from this we'll get like, so both the terms, the two terms, you'll get this as 0. So you'll get one as y is equal to x and the other one as xy is equal to minus 1. So these are the two solutions that we have got from this. Okay, from these two we get y equal to x or x is equal to y, anything we can write down. Fine. Now according to the 1 to 1 function, if I take f of x is equal to f of y, if I get only x is equal to y means then I can say it is 1 1. But here though we have considered like f of x is equal to f of y, I got x is equal to y, but even xy is equal to minus 1 also the other condition that I have got here. Okay, now here from this I can write x is equal to minus 1 by y, and since I've got other than x is equal to y, we can say here it is not 1 to 1. We'll say that it is not 1 to 1. Okay, so just like this, if I just say like 1 to 1, then you may get confused and you'll have doubts why it is 1 to 1 or why it is not 1 to 1. So for this let me take some example. Let us consider f of 2. Okay, if I take f of 2, if I substitute in this function, you'll get 2 by 2 square minus 1. So if I simplify, you will get 2 by 4 minus 1, which is nothing but 3. Now let us take the other value like minus 1 by 2. Okay, this is the best example that they are given in the textbook. So if I take minus 1 by 2 and substitute in our function, so you will get in x place minus 1 by 2 divided by minus 1 by 2 the whole square minus 1. So try to simplify this. Minus 1 by 2 whole divided by 1 by 4 minus 1. So minus 1 by 2 divided by, if I take LCM in the denominator, you will get minus 3 by 4. So minus minus gets cancelled. So numerator term is 1 by 2. Denominator term, if I bring it to the numerator, you will get 4 by 3. Okay, so cancel this for 2 times. So your answer is 2 by 3. So from this, what does it mean? Even for f of 2, we got it as 2 by 3. For f of minus 1 by 2 also we have got it as 2 by 3. So two different values, two domain values are getting same y value. Okay. Now this, if I show even by taking a Venn diagram, you will find it very easy. So here the range, the domain are nothing but all real values except plus or minus 1, and this codomain values we can take all reals. Okay, from here. Now here if I take 2, so I am getting 2 by 3. Okay, from this. So 2 to 2 by 3. Suppose if I take minus 1 by 2 here, and even minus 1 by 2 also I am getting the same value called 2 by 3. So from this, what we can say, see, two different elements. Okay, the different elements should have different images, then only we'll say that it is one-to-one function. But here these two different elements are having the same image called 2 by 3. So clearly it is not one-to-one function. Thank you, children.